Hi everyone, welcome to my channel. Myself Ram Reddy. I am studying computer science and engineering in SVC Bengaluru. Today we will discuss about physics of animation. Course overview. Physics of animation is an introduction to the principles and concepts of physics relevant to animation and special effect. Introduction to animation. Three basic types of animation: traditional, computer, and stop motion. Why should take this course? This course is most interesting for animation or illustration art majors, ideally concurrent with Art 114, film majors, non-science majors interested in animation and special effects. This course is less interesting for science and engineering majors will probably not find this course to be useful because they cover the same physics in their required courses. Animated feature films. 3 of the top 10 films of 2009 were animated feature films. Combined domestic gross of near $700 million. Live action films. Animation is also important in creating special effects for live action films. Compositing. Animation is blended into live action films by compositing, which combines two or more separate images into frame of film. For example, all the green pixels in the left images are replaced with a computer generated weather map. King Kong. Animated compositing has advanced enormously from the original King Kong to the remarks. Diversity in animation. Animation is more than just Hollywood CG blockbusters. Video games. The gaming industry is even bigger than Hollywood, and animation is very important. Modern Warfare 2 grosses $300 million in first 24 hours. Good animation is hard. Even with modern software tools, it is difficult to create high quality animation. Something as simple as a bouncing ball isn't easy to animate believably. Rotoscoping. Animation is art, so producers have tried alternatives such as rotoscoping. Scene is filmed and animator trace the images, used when the motion is too difficult for animators to capture effectively. Rotoscoping in films. Rotoscoped animation is very noticeable, so typically it's used sparingly in films. Rotoscoping pointers in modern films are mainly used to white out elements in a frame so that CG animation can be composited in. In-camera motion capture. In-camera motion capture system was developed for the characters in the Pirates of the Caribbean sequel Dead Man's Chest. Motion capture techniques continues to advance because directors want to capture actors' performances. Good news and bad news. Although rotoscoping and motion capture are useful for thinking like facial animation, they simply can't match the work of good animator. That's the good news. Creating good animation is hard. That's the bad news. How could it be made easier and better? Physics and animation. To create realistic animations, animators need to understand principles of mechanics. Architects and artists. A perspective drawing by an architect needs to be highly accurate with precise measurements. Artists, on the other hand, usually don't need such mathematical precisions. It just has to look right. Surgeons and illustrators. Surgeons and artists learn anatomy but for very different purposes. Engineers and animators. An engineer's calculations of motion needs to be highly accurate with precise measurements. Animators, on the other hand, don't need mathematical precision, but the motion has to look believably. Newton's second law. The greater the force acting on an object, the greater the acceleration of the object. The greater the mass of an object, the less it accelerates when acted on by the same force. Free fall acceleration. Newton's second law explains why heavy and light objects fall with same acceleration. Ratio of weight to mass always the same since weight depends on mass. Newton's third law of motion. For every action force, there is an equal reaction force in the opposite direction. Real world and animated world. Understanding real world helps in creating interesting animated worlds. Animation follows the laws of physics unless it is funnier otherwise. Art Rabbit, Disney animator, director and creator of Goofy. Physics engines. Animation and gaming software such as Maya have sophisticated physics engines that use the laws of physics to compute motion. Easier to use these tools knowing physics. 4 A's of animation. In his book Animation, The Mechanics of Motion, Chris Webster lists the following 4 levels of animated motion that are activity, action, animation, acting. These categories are best understanding by considering special examples. Activity. The opening sequence in the Star Wars movies is good example of activity, the lowest level of animated motion. The motion is arbitrary without constant of physical laws. Action. Action is the level of animation when objects move according to physics laws such as bouncing ball or a waving flag. Animation. At the level the motion not only follows the physical laws but is also intentionally, such as bird flapping its wings or a human jumping. A walk cycle or a jump test are at this level. Acting. At the highest level, not only is the motion intentionally but it also conveys personality. 4S animation. Activity, action, animation, acting. Understanding physics helps animators achieve the second and third levels, the highest level. Acting cannot be achieved without first creating animated motion that's believable. Walking, running and jumping. What forces accelerate us into motion when we walk, run or jump? Jumping. Jumping is done by pushing downward on the ground, so the ground pushes upward on you. How high you jump depends on the force and the distance over which apply that force. Walking forward. Back foot pushing back on the floor. Reaction is the friction of the floor which pushes your body forward. If floor is frictionless, then it is impossible to move forward. Thank you.